intuitively, the theorem is clear. If you have a fixed point of this function, this means that P coincides with f of P. In other terms, there is no need to alter the components of P in this way. But this happens if every component of Z plus OP is equal to 0. In other terms, there are no positive excess of the 1. It is sufficiently clear. But let us prove the theorem rigorously. Since function f verifies all the properties, all the assumptions, of Brouwer fixed point theorem, there will exist a price system P star in delta such that f of P star is exactly equal to its image, P star. Simply you have that this function is equal to P star. Let us write. This inequality can be rewritten in this way. P star is equal to P star plus Z plus of P star on the sum of a Pi star is equal to 1, because the original price system P star is an element of delta. So you can write 1 plus sum for I of Z plus I of P star. Fixed point theorem guarantees the existence of a price system P star which verifies this equality. Now, the remaining part of the theorem is simply calculation. Why? Multiply both hands of this equality by this denominator, which is a positive number, of course. You obtain P star times 1 P star plus P star times sum for I of Z plus I of P star. On the other side, P star plus Z plus of P star. Simple calculation. But clearly you can simplify this vector and you obtain this equality. P star times this sum is equal to Z plus of P star. Second step, multiply both hands of this equality by the original excess demand vector, not Z plus of P star, but Z of P star. You obtain P star times Z of P star times this sum which is equal to Z plus of P star times Z of P star. Observe, I multiplied both hands of this equality by the original vector Z, not by Z plus. Why? It's simple, because by Barra's law, this inner product is equal to 0. So, the left-hand member is equal to 0, and you obtain the following result. Z plus of P star times Z of P star is equal to 0. Question: can z of p star have some positive component? No. Why? Because if z has a positive component, also z plus has a positive component, which is exactly equal. And therefore, the product of two positive numbers is another positive number. And so, for every component of original z, which is positive. For all the components, negative or null in the original vector, z plus substitute is zeros. So, every negative component or null component is multiplied by 0. So, in this inner product, the product between the negative component of original z by 0 give 0. And the possible positive component of z plus, give a positive component also in z. Therefore, if the original z had some positive component, this inner product would be a positive number. Contradiction. And therefore, z of p has all no positive component. In other terms, z plus of p star has all null component. Equilibrium. According to our previous definition. Suppose, for the sake of an example, suppose that a vector z of p has component plus 2 minus 3, then z plus of p has component plus 2, 0. And when you compute the linear product between these two vectors, you obtain 2 by 2, 4, plus 0 by minus 3, 0, 4. Note, if the original vector has a positive component, also this linear product gives a positive number. And therefore contradicts this equality. Therefore, I repeat, z of p star must have all non-positive components. In other terms, z plus of p star has all null components. Well, right, and then shall repeat all the proof. The function f, defined by means of this modified form of Arrangement Tatomma, is continuous. It is defined in delta and takes values in delta. But delta is non-empty, compact and complex. So we can apply the fixed point theorem by Gruber, and this means that there exists a p star such vector p star is equal to f of p star. Since f of p star is equal to p star plus z plus of p star all 1 plus the sums of the components, the sum of the components of this vector, you obtain this equality. At this point, multiply both ends of this equality by this denominator. You obtain p star times 1 p star plus p star times this scalar, p star times this scalar, and on the right hand side you have the numerator, p star plus z plus or p star. P star and p star can be simplified, and you obtain in the end this equality. P star times this scalar is equal to z plus of p star. This is a vector equality. But now, multiply both sides of this equality by z of p star, the original vector of excess of the map. You obtain p star times z of p star times the scalar equal to z plus of p star times z of p star. By Barre's law, this inner product is equal to 0. So all the left-hand side of this equality is equal to 0. And therefore, also the right-hand side, you obtain this equality. Is it possible that the original vector z has some positive component? The answer is clearly no. Because if, for example, the first component of z were a positive number, by multiplying by the first component of z plus, which is equal, you obtain a positive number. While all the negative components are multiplied by 0. So the inner product would be a positive number, contradicting this equality. Therefore, z of this time must have all non-positive components. In other terms, there is an equilibrium in the price system P star. A fixed point of a function f is in reality an equilibrium for the common. This is the simplest way which you can apply the Brouwer's theorem in order to prove the existence of equilibrium. Let us add another short break.